Hi, this is Saber Abdoli and I want to explain my research interests, backgrounds and future goals through this presentation. I am interested in third and fourth GI generations, especially in WebGIS and context-aware GI systems. I want to have a contribution in geospatial revolution, designing innovative GI systems with various applications, developing current GI systems and science. The first independent research that I want to explain is a context-aware spatial information system for drivers' safety. This research was my master thesis and took me about 1 year. According to the World Health Organization, a traffic accident means more than 1 million yearly deaths, millions of yearly casualties, and billions of economic costs. Each traffic accident has 3 main causes: driver, vehicle, and road. Researchers found that more than 90% of traffic accidents happen due to drivers' fault. To respond to this problem, many different advanced driver assistance systems have been developed. Collision avoidance systems, traffic sign recognitions, and lane departure warning systems are samples of such systems. There are many different situations in a driving process that current advanced driver assistance systems cannot able to realize. Some of them related in spatial relations between vehicles, some other related in considering condition of transportation infrastructure, and even realizing each vehicle internal context. We distinguish 3 different physical sources in driving activity: vehicle internal context, other near moving object context, and transportation infrastructure context. Our proposed systems have 3 main advantages against previous systems: more reasoning ability, it is able to consider different parameters simultaneously, and potentially able to provide some part of essential information for a driverless car. For presenting vehicles spatial context, we chose dynamic zone of influences that its length is a function of different parameters such as vehicle velocity and driver's alertness. XML-based self-description also selected to present zone of influences spatial properties and vehicle attributes. We utilized each vehicle spatial properties through XML-based self-descriptions to find spatial relations. The computing would be initiated between 2 near vehicles when there was an overlap topology relation between their zone of influences. To detecting overlap topology relation, we suggest a simple mathematical algorithm. This algorithm at the first step uses radius of zone of influences x circles and distance between their centers to check the topology relation. If the situation was like a part A, it is obvious that 2 zones are disjoint. Otherwise, we need more scrutinize to find the exact topology relation. To find the exact topology relation, algorithm have to compute Zoe's lines intersection coordinates. As you can see in this figure, only part C situation would return overlap relation. In the overlap relation case, other spatial relations between 2 Zoes would be computed, and the results would be added to each vehicle's XML-based self-descriptions. We need a high level of detail transportation infrastructure data model for our application. Static information such as speed limits and dynamic information like a weather condition should be manageable through this model. We select traditional arc and node data model with a separate lane information to handle our transportation infrastructure context. You can see system architecture of our proposed system through this figure. This system in the first layer would collect related information such as vehicle context and road conditions. In the second layer would reason about safetiness of current situation. And in the third layer, deliver essential information to the driver. To reason about safetiness of different driving situations, we utilize a rule-based reasoning engine. Many rules defined in a rule base, and when some concurrent rules matched with our defined patterns, the system would fire an information service for driver. Next independent research backgrounds that I want to explain is a distributed web-based GIS for tourist trip planning. A tourist should consider a lot of parameters when wants to make a plan for the trip. Time limits, financial plan, and pursuing interested activities during the residency are among main tourist concerns. Our trip planner system in the first step would collect user interest and constraints. Accordingly, a content-based filtering method would omit unmatched routes in a system database. After that, the system should check the service availability of remaining routes by connecting to the service center database. An analytic network process would run to rank available options, and then a traveling salesman problem algorithm would run to find the optimum path between high rank options. In the final step, system will match time schedule with the user time constraints and present the plan to the tourist. Tourists would be able to add or remove some options in the suggested plan and customize it. Thanks for watching this video.